Our topic for today is radio wave propagation fundamentals. So here are the lesson objectives. So after this lesson and discussion, so you should be able to, number one, define free space electromagnetic wave propagation. Number two, define electromagnetic wave polarization. Number three, define and describe the terms rays and wavefronts. Four, describe a spherical wavefront. 5. Explain inverse square law. And lastly, define and solve the optical properties of electromagnetic waves. Okay, so radio wave propagation. So this is another topic. So we're done with transmission lines. Okay, so let's review first the communication system. So this is a diagram ko. And so the transmission line, so as we have discussed before, so ang purpose ng transmission line, di ba, siya yung nagko-connect dun sa, so mga cables yun na ginagamit natin to connect transmitter and the receiver or the load. So for example, for this system, the load is this antenna, okay? And the transmitter or the source of the signal is this transmitter. So if you want to connect your transmitter to the antenna, which is the load, so gagamit ka dun ng transmission line. Same with dun sa receiver. Okay? So that is the purpose of the transmission line. So this is the transmission line for the receiver and the transmission line for the transmitter. So that is the wired section of the system. Okay? Then you're going to use the antenna and to radiate the energy or the signal sa space. So this is the Earth's atmosphere or the space. So paglabas ng signal dyan, so yung pag-travel ng signal or yung pag-propagate niya, so that is the what you call radio wave propagation. Okay? So kapag kasi na-radiate na yung signal sa antenna, so we need to analyze on how this signal behaves. So paano siya magta-travel from the transmitter to the receiver. And kung ano yung mga nakaka-affect dun sa signal natin while nandun siya sa space or sa atmosphere ng Earth. Okay, so that is our lesson for this day. So the radio wave propagation. So we're starting with of course, the fundamentals. Okay, so we need to learn first the fundamentals before we go to the modes of propagation. Okay, so again, radio wave propagation is the process by which the waves travel through a medium. So dito, dun tayo sa atmosphere ng Earth. So we're gonna focus on the travel or the propagation of the wave dun sa space or dun sa Earth atmosphere. So anong nangyayari kaya dun sa signal natin kapag lumabas na siya ng antenna? So the purpose of antenna is to convert, no, di ba yung signal sa cable or sa transline is an electrical signal or electrical yung form niya. So electrical signal siya or electrical energy siya dun sa cable. So the purpose of antenna is parang transducer yan. When you say transducer, so siya yung taga-convert ng signal from one form of energy to another form of energy. Okay? So in order for the signal to propagate or to travel sa Earth atmosphere, so kailangan ano siya, electromagnetic wave yung form niya. Okay? So yun yung ginagawa ng antenna natin. So kina-convert niya yung electrical energy sa electromagnetic energy. So para mag-propagate yung signal mo sa Earth atmosphere. Okay? So we're gonna focus with the properties of that waves. So electromagnetic waves are also known as radio waves. And so other terms sa kanila is radio waves. So they are forms of radiant energy such as heat, light, X-ray waves. So parang mga ganyan sila, yung mga kamukha niya. So they are considered oscillatory disturbances in free space. Okay? So we have this nomenclature for the frequency bands of the electromagnetic waves. So let's zoom ng konti. And so this is parang same lang din sa ano natin, dun sa spectrum, yung electromagnetic spectrum, if you can recall yung table na yun, di ba naka-arrange sila kung ano yung very low frequency, yung mga ganun, eto. So that is the frequency band designation. Okay? So recall nyo yung range of frequencies from very low frequency to the extremely high frequency. So these are the frequency band that are considered to be radio waves. Okay, so ito yung mga radio wave signals natin. Okay, so ibig sabihin, pag sinabing radio wave, so sila yung frequencies na pwede mong gamitin for wireless communication. So sila yung pwedeng mag-travel sa atmosphere ng Earth. Okay, so meron din silang metric designation. So this metric designation is galing dun sa wavelength nila. Okay, so if you will compute the wavelength, so nasa myriameter, kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter yung range ng wavelengths. In terms of frequency, ito yung designation. No, yung very low frequency, yung low frequency, yung medium frequency, and so on. But for metrics, so ito yon. If you can memorize, no, or remember yung mga to, mas maganda. So, kailangan alam mo kasi yung tawag dun sa range at saka dun sa frequency band and dun sa metric designation. For example, so kapag tinanong 30 to 300 gigahertz, so they are also known as what? So they are also known as millimetric waves. Okay? So try to memorize or familiarize the designations of the frequency bands. So this is a standard actually dun sa mga frequency natin. Okay, and then the propagation mode. So we actually have three types of propagation mode. So the ground wave, the sky wave, and the space wave. So explain ko lang briefly yung tatlo, but we have separate discussion for that. So these are the three mode of propagation. So ito yung tatlong paraan or main modes of propagation. So the first one is the ground wave. So if this is your antenna, okay, so antenna mo to, and then you're going to propagate your signal using ground wave. So ganito yung propagation niya. Okay, so meaning sa ground nagta-travel yung signal. And then when you're going to use the space wave, so you have this another antenna. Space wave is actually yung line of sight communication. So straight yung propagation ng signal mo. And the sky wave is pataas. Tapos bumabalik siya sa Earth. So tumatalbog yung signal mo dun sa layer ng atmosphere which is known as the ionosphere pabalik dun sa Earth. So pinapa-reflect, parang ganun yung parang ganun yung nangyayari dun sa signal. So parang nagre-reflect siya dun sa layer ng atmosphere sa taas pabalik sa Earth. That is known as the sky wave. Okay? So basically, dun sa mga frequency natin, yung low frequency signals, so itong mga to, yung very low frequency up to the medium frequency, so they are using ground wave. Okay, so pang low frequency yung ground wave. And then for high frequency, so pang space wave yun. Okay, yung sky wave, so it is mainly used for high frequency. So kasi yung mga frequency natin or yung mga signals na to, so hindi lahat is nagre-reflect or parang nagba-bounce back pabalik. Okay? So ito kasing mga low frequency, if you will going to propagate them using sky wave, so ma-absorb lang sila ng layer ng atmosphere. So they will not bounce back pabalik sa Earth. So that's why they are not used for sky wave. Ito naman, so the tendency of high frequency, when you try to propagate them using sky wave, so hindi rin sila nakakabalik or nagba-bounce back kasi nagpe-penetrate sila dun sa atmosphere or dun sa ionosphere nga na layer. Okay? So nagpa-pass through dun sa layer na yon since mataas yung frequency. So there's a certain frequency that can bounce back dun sa ionosphere, so that is the high frequency. So itong band na to. Okay? So ayun, so that's the brief introduction between the three modes of propagation. So we will explain them in detail sa next lecture. Okay? So, next. So, like what I've said kanina, kailangan yung wave natin or yung signal natin is in electromagnetic form or electromagnetic wave. So, kailangan ganito yung form of energy ng isang signal para mag-propagate siya sa atmosphere ng Earth. So, when you say electromagnetic, kaya tinawag siyang electromagnetic dahil dalawa yung components niya. So, it has the electric field component and the magnetic field component. So, those two components of the signal or the wave, so perpendicular sila. Okay? So, dalawa yung components and those components are perpendicular to each other. So, kumbaga parang dalawang parts yung signal mo, yung electric part and the magnetic part. So, para mabuo yung tinatawag na electromagnetic wave. So, this wave is the EMW. Okay? So, ganyan yung parang representation sa kanya. Kasi hindi naman natin nakikita yung mga waves. So, they are not visible sa naked eye. Okay, so next. And so, regarding naman dun sa wave propagation velocity or yung bilis ng pag-travel ng wave, so this is approximately equal to the speed of light, which is 3 times 10 raised to 8 meter per second and 186,000 miles per second. Okay? So, unlike din sa coaxial cables and other cables, so, yung velocity factor dito is considered 1 kasi nasa atmosphere siya ng Earth. Okay? So, that's why approximately 3 times 10 raised to 8 or parang kasing bilis ng light signal yung propagation ng isang electromagnetic wave sa space. Okay? So, remember, if you want to solve the frequency, so just use the speed of light as the velocity of propagation. If you want to solve the wavelength, so di ba meron tayong relation dun sa tatlo? So, ayan. Okay? So, C over F lang kapag sa wavelength. Kasi ang velocity factor natin, ang assumption natin kapag sa atmosphere, that is equal to 1. Then, yung orientation naman nung dalawang components, kasi nga dalawa yung components ng wave mo. So, you have the electric field and the magnetic field. So, they are perpendicular with each other. So, the orientation of the components, so ang tawag doon is yung polarization. Okay? So, there are various types of polarization ng mga signal. So, we have the linear polarization, the circular polarization, and the elliptical polarization. Okay? So, itong dalawa, they are considered as rotating. So, yung circularly polarized and the elliptically polarized. When you say linear polarization, I have a figure dito. Yan. So, the linear polarization, so dito ang tinitignan natin yung component ng electric field. Okay? So, what does it mean? If the electric field is horizontal, then the polarization is horizontal. Okay? So, again, diba 90 degrees nga sila. So, if yung orientation ng electric field is horizontal, meaning nakaparallel siya sa surface ng Earth, while yung magnetic field mo is nandito, then, yung polarization nito is horizontally polarized. Ayan. Then, kapag baliktad, so this one is considered as the vertically polarized. Okay, so depende siya dun sa, ang tinitingnan bale kapag sa linear polarization, yung orientation ng electric field, not the magnetic field. So, dun tayo nakatingin sa electric field. So, kapag nakahiga yung electric field, then horizontal siya. Yung polarization. Kapag nakatayo yung electric field, so, vertical yung polarization. Okay? So, ganun lang naman yung difference between the two. So, those are the linear polarization of the signal. However, if the signal is rotating, kagaya nga nito, okay, and then equal yung strength no electric field and a magnetic field, then the polarization is considered to be circular. Okay? Pag sinabing equal yung strength, so equal yung parang, ayan, so this is, kunwari, this is electric, this is magnetic. Tapos equal yung strength nila, so meaning pantay ito, yung dalawa. Then pag umikot yan, so para siyang circle. Diba? Okay, so kaya tinawag siyang circular. Then kapag merong mas malakas din sa dalawa, meaning hindi equal yung strength nila, so kunwari mas malakas yung electric field, so mas mahaba siya, tapos ito yung magnetic field mo. For example, ganyan. Then kapag umikot yan, so since hindi pantay yung strength ng dalawang components, then hindi circular yung magiging appearance niya. So it will become elliptic. Okay? So it is considered to be elliptical polarization. Okay? So that's the difference between circular and elliptical. So kapag same yung strength ng dalawang components, then it is circular. Pero pag merong mas malakas din sa dalawang components, then it is elliptical. Okay? So those are the different polarization na meron yung mga electromagnetic wave natin. So it can be horizontal, vertical, circular, or elliptical. Okay? Next, so I'll just add this one. So ano ito? So this is a phenomenon which is known as the Faraday's rotation. So the Faraday's rotation is due to the atmosphere of the Earth. So, for example, if tinransmit mo yung signal mo na vertically polarized siya, then pagdating sa receiver, medyo nakaslant siya ng konti dun sa receiver. So meaning, it is affected by the so-called Faraday's rotation. Okay? So, ang nangyayari kasi pag yung wave na tinatransmit natin or nagpo-propagate sa space, so habang nagka-travel siya, nagkakaroon siya ng slight rotation. For example, hindi naman siya dapat mag-rotate since linear polarization nga siya. For example, vertically polarized yung signal, wherein dapat vertical lagi yung electric field, kaya lang medyo slight, ano siya, parang slant ng konti. So, that is due to the Faraday's rotation. Okay? So, yun yung tawag dyan. So, that is actually a loss. Kasi ang ideal natin, if you transmit a signal vertically polarized, it should be received dun sa receiver na parehas yung polarization. However, due to Faraday's rotation, there is some slight difference dun sa orientation. And that slight difference can result with the loss. Okay? So, yun yung problem lang natin kapag affected yung signal natin sa Faraday's rotation. So, actually, this is always present dun sa signal. So, hindi naman laging perfect yung mga system natin. There's always a loss dun sa system. Okay? So, again, Faraday's rotation is the phenomenon wherein yung signal natin is nagkakaroon ng konting change dun sa polarization niya, especially kapag horizontal or vertical siya. So, nagkakaroon ng konting mismatch dun sa polarization. Okay? So, that's what you call the Faraday's rotation. Next, if napansin niyo yung mga kanina, balikan natin. Yung dinadrawing ko. Yung dito sa umpisa. Ayan. So, nag-drawing ako ng mga parang arrow. Tapos dito, nag-drawing ako ng mga ganito. So, ano yung significance ng mga illustration na to? So, ang tawag doon ay rays and wavefronts. Okay, so rays and wavefronts. So, the importance of the rays and wavefronts is para sa analysis ng propagation. Since hindi nga visible sa naked eye yung electromagnetic waves, so we need to analyze them using illustrations. So, these illustrations, yung mga rays, itong mga to, so rays yung tawag dyan. Then yung mga pagganito, yung mga curves, so that's the wavefront. So, yan yung way natin to show on how the signal propagates. Kasi nga, hindi natin nakikita. So, ginagamit natin yan for the representation on how the signal propagates or on how the signal travels dun sa atmosphere. Okay? So, para alam natin kung saan papunta, for example, if we have the source, nag-radiate siya ng signal, so we can illustrate yung radiation ng signal by using a ray that is pointed papunta doon. Pwede rin dito, dito, or we can use a wavefront to show on how the spreading of the signal. So that's the importance or the purpose of the rays and the wavefronts. So these are for illustration purposes. Okay? So para alam natin kung saan yung direction ng signals propagation or signals travel. Then another parameters that we need to know is these two parameters. I'm sure familiar kayo dito. Na nasa calculators natin to. If you're using this calculator, say model, this is FX570 PS Plus, this is Casio. Okay, so if ganito yung calculator, so nandito siya sa constant number 32. So this one is the relative or the absolute, no, absolute. So this is absolute. Pagka ang subscript niya is O, so that is absolute. Yung relative is mu R ER. Okay, so remember this constant? So, di ba ito, yung dielectric natin to sa ano, sa transmission line. So, the absolute permittivity is nandun sa constant number 32. So, itong value na nandito, so ito kasi yung exact value niya. Okay, na na-derive. So, pero kung gusto mong kunin sa calcu, so ganito na siya. Equal lang to. So, remember the unit? So, the unit is farad per meter. And then, yung constant number 33, so yun naman yung absolute. Okay, so the absolute permeability. Ayan, so this one. So this one is expressed in Henry per meter. So recall, doon sa transmission line, we have this formula for ZO. So remember this formula dun sa transmission line? We have this formula. So the inductance per meter or per length and the capacitance per meter or per length. So when it comes sa space or dun sa free space or sa Earth atmosphere, so meron din kasing ZO, yung atmosphere. Since ginagamit natin siya as medium and nakakapag-travel yung electromagnetic wave through that space, so meaning meron siyang characteristic impedance. And we can actually compute for the ZO of the free space using these two parameters. Okay? So, di ba ito is related dun sa electric property. Ito naman is related dun sa magnetic property. So, since naka-express din yan for, as Henry per meter and Farad per meter, then we can actually compute for ZO using these two parameters. Ang gagawin mo lang dun is get the square root of the two constant. So, kumbaga, ito yung magsisilbing, itong mu, ito yung nagsisilbing inductance per meter ng free space. Tapos itong isa naman, ito yung nagsisilbing capacitance per meter ng isang or ng free space. So, getting that value, so divide mo lang naman sila. So, the other one is constant number 32. We will get 376.73. This is approximately 377. So, constant kasi ang free space impedance. So, that is the constant. 377 ohms. So, I think constant din yan sa calculator. I think number 37 siya. Ayan. So, that is the ZO of the free space. Okay? So, that is 376.73. So, equal lang din yan dun sa kanina. Nung kinuha natin tong value nito. Okay? So, ayun yun. So, kapag pure air siya. Kapag sa Earth atmosphere kasi, since hindi naman pure yung air, so hindi naman actually saktong-saktong 1 yung relative permittivity niya. So, nilalagay pa siya dito. Pero sa sa computation, so we approximate that the Earth atmosphere, yung relative permittivity, so ina-approximate na natin to as equal to 1, no? So that's why okay na yung 377 na gamitin sa computation. So no need na ito. So, pinakita ko lang dito na hindi naman talaga siya eksaktong equal, kasi meron pa rin namang konting-konting difference doon. Pero in computation, so we are assuming na lang na 1 na din ito. Okay? So for simplicity. Okay? So you can actually use 377 compute for the or in computation kasi mamaya may mga computations tayo, then you're going to use the impedance of the space. So that is 377 by ohms. So next, so ito nga sila. So saan mo ba gagamitin to? Yung mga constant na yan. So gagamitin mo yan kapag pinapakompute ka ng ganito. So the power density. Okay? So the power density is the amount of power per unit square or per area. Okay? Per area siya. So, ang formula niya is power all over area. So, kaya ang unit niyan kapag SI. So, the unit is watts per meter squared. So, it is commonly expressed in that unit. So, pakatandaan yon. So, the unit of power density is usually watts per square meter. Okay? Then, other formulas na related sa power density. So, we have this one. So, ano ibig sabihin ng letters E at saka H? Letter E is the electric field intensity. Letter H is the magnetic field intensity. Okay, so electric field intensity for the letter E and electric field intensity for the letter H. So, may mga unit din to. So, itong electric field intensity, so para siyang voltage. So, it is expressed in volts per meter. The magnetic field intensity, like, it is letter H. So, ang ano naman ito, unit is para siyang current sa ampere per meter. Okay? So, kumbaga, kung i-imaginein mo yung formulas na to, so, yung E parang voltage. Yung H parang current. Then yung 377, yan yung parang resistance. So, recall dun sa basic electricity. So, we have this formula. Okay, so nakikita niyo ba yung resemblance nung basic electricity natin na formula dun sa tatlong to? So, di ba, parang similar sila. So, kaya madali lang tandaan to. No? Kung given yung dalawa, di ba parang voltage kasi to, parang current to, so, para ka lang nagpi-PIV dun. Okay? Then, ito naman, para siyang B squared over R, wherein yung R natin kasi, so yun yung impedance ng space, so it is constant na 377. For the other formula, so para siyang I squared R naman. Okay? So, again, the units. So, this is volts per meter, yung electric field intensity, then amperes per meter for the magnetic field intensity. Then, for the power density, so that is watts per square meter. So, yung power density kasi, so parang siya yung power dyan. Okay? Pero, density kasi siya. When you say density, so it is per unit area. Okay? Per square unit siya. Next. We have this so-called isotropic source or the point source. When you say isotropic, so it is a point source, a theoretical source of signal wherein it radiates the signal uniformly in all direction. Okay, so ganun yung definition for the isotropic. Yan. So it's a theoretical source of signal wherein nire-radiate niya yung signal natin uniformly in all direction. So meaning, yung itsura nung parang ano niya, ayan, yung wavefront niya is spherical. Okay? So para siyang bilog na bola. So if you are going to compute for the power density, so kasi ina-assume natin minsan na parang point source yung source ng signal, so we can use this derived equation for the power density. So, anong ginagawa dito? So, parang ito yan, no? I-ano lang siya, in-expand lang yung formula. Kasi ang general formula to compute for the power density is the power all over the area. So if it is an isotropic source or a point source, or kung given yung power and yung distance between the source, then you can compute the power density using this equation. So anong meron sa equation? So you have the power radiation or power radiated. Okay, the power. So in watts. 4 pi. Then yung R dito is hindi ano nga. So that is the distance yan. When you say distance, kung gaano kalayo doon sa source yung measurement mo. For example, you want to determine kung ano yung power density kung nasa 1 kilometer ka away from the source, then you can compute that using this formula. Pero dapat alam mo yung power na nire-radiate nung source. And then kung gaano kalayo dun sa source, so that is the distance. So in meters dapat to. Okay? So if you observe the formula, this is actually based dun sa surface area ng sphere. Since point source siya, so it radiates the signal uniformly in all direction. So ang shape ng kanyang wavefront is spherical. So remember the surface area of sphere. So the surface area of sphere is 4 pi r squared. So yan yung assumption dun sa point source. So kaya naging ganyan yung formula mo. Okay? And then another formula is for the electric field intensity. So ito yung volts per meter. So nag-derive din sila ng formula doon kung given yung P at saka yung R. So if given yung P and R, so you can use this derived formula. Square root of 30 multiplied by the radiated power all over the distance. So this is a derived formula for electric field intensity. So din-derive lang yan using this one and this one. Okay, so pinag-equate nila ito tsaka ito. So you can actually try that. So ito tsaka ito, pag-equate mo, then ihiwalay mo dito yung E. So magiging ganyan yung result ng equation. Okay, so you can actually prove that using these two formula. Okay? Pero since dinerive na, so you can actually use this directly sa computation. If you want to compute for the volts per meter or the electric field intensity, so given yung power and yung distance, so you can use this direct formula. So for example, we have some examples dito to practice using the formulas. Sample problem 1. So for an isotropic antenna radiating 100 watts of power, so determine the power density at 100 meters from the source, the power density at 2,000 meters from the source, and the electric field intensity for 100 meters. So doon muna tayo sa part A. So the part A, power density at 100 or 1,000 meters from the source. So given yung power and yung distance, tinatanong to. So we can use the equation or the formula. So ano ba yung formula natin? So the power over 4 pi r squared, di ba? So again, the formula is, this is for part A, power density so what is the power radiated? 100 watts. Then the distance is 1,000 meter. So let's calculate. So 100 all over 4 pi, the distance. So meron siyang 1,000 meters from the source. So this will be the power density, 1,000 meters from the source. 7.96 microwatts per square meter. Okay? So ano kaya mangyayari daw sa part B if dodoblehin natin yung distance? So lalayo tayo ng 2,000 naman. So same formula ulit. Ayan, so papalitan lang natin yung distance. So dinoble niya yung distance. So let's see what will be the effect on the power density. It will become 1.99 microwatts per square meter. As you can see, nung nag-increase yung yung distance natin from the source, so nag-decrease yung power density. Okay? So that is the relation of the two parameters based dun sa formula natin dito. So kapag nagdi-decrease ito, so nag-i-increase naman yon. Or kapag nag-i-increase to, nagdi-decrease to. Okay? So they are related based dun sa formula. So they are related as ganito. Okay? So ito yung relation nila. So the power density is inversely proportional to the distance na naka-squared. This is actually known as the inverse square law. Okay? The inverse square law. So the power density and the distance between the source and the observer so are related by the inverse square law. So remember this relation. Okay? So letter C, meron pa siyang pinapasolve na isa. So what is the electric field intensity for 1,000 meters? So yung power nga natin is 100 watts. So we can use the derived formula for part C. So yung ganito. So the power radiated will be 100 watts. Then the distance is 1,000 meter. Yan. So you'll get 54.77 millivolt per meter. So the unit is volts per meter. Okay, so practice using the prefixes such as milli, micro, nano, pico. Okay? So kapag mga ganitong values na yung nakukuha ninyo sa calculator, so use the metric prefixes. So that is the correct way on expressing this answer. Okay? So tama naman itong sagot nito. Kaya lang, since maliit kasi yung value, then you can use now the milli na prefix dun sa unit. Okay? Same with this one. Sobrang liit na niya. So, kailangan gamitin mo na yung micro to express the answer. Okay? Next. So, another sample problem. A 500 kHz antenna radiates 500 watts of power. So, the same antenna produces a field strength equal to 1.5 millivolts per meter. So, if the power delivered by the antenna is increased to 1 kilowatt, then what would be the expected field? So this is field. Nagkabaliktad yung letters. So what would be the expected field intensity? So ang sabi niya, so una, so you have this power, let's say 500 watts. Then yung field strength niya, which is yung E, that is 1.5 millivolt per meter. So ano daw yung magiging field strength if yung power magiging, so this is power 2. So what will be the field strength for that power? Okay, so we're going to relate the two. So kapag ganitong problem, sa relation lang yung tinatanong, so you can actually use the formula na meron tayo. So yung ganito. Yung kanina, yung 30. Yung ginamit natin sa part C ng problem number 1. Okay, so wala naman siyang nabanggit regarding dun sa distance. So ang ginawa lang daw, kung 500 siya nung una, tapos 1.5 millivolts per meter yung field strength, so ano yung magiging field strength if magiging 1 kilowatt yung power? So relation lang ito. So based na sa formula, so directly proportional yung power dun sa field strength, kaya lang naka-square root dapat yung power. Okay? So using ratio and proportion, you can actually compute that directly. Ayan, so ganyan gumawa ng relation using this relationship. So, ratio and proportion lang. Okay, so what is the field strength 1? So that is 1.5. So hinahanap to. So PRAD 1 is 500. Then PRAD 2 is 1 kilowatt. So E2, so ito transpose mo lang doon tsaka to. So magbabaliktad lang siya. So magiging 1.5 to divide. Okay, so the field strength should be 2.12 millivolts per meter. Okay, so since directly proportional kasi sila, ayan. So expect mo dapat na kung nagdoble ito, so dapat tataas din ito. Pero hindi siya doble kasi nga square root, may square root ka pa doon. So hindi sila directly. Okay, so they are directly related. However, may square root kasi yung power. Pero dapat expect mo dito na yung sagot mo is mas mataas dun sa 1.5 millivolt per meter. Okay, so ito yung eksaktong sagot niya. 2.12 millivolts per meter. Okay, so again, so try to resolve these two problems in your own para ma-memorize niyo yung mga formulas na ginamit natin. Next. So we have these two terms, or what we call the attenuation and the absorption. Okay? So yung attenuation, nabanggit ko na to before. So the attenuation nga is the reduction of power or yung pagbaba ng power level ng signal habang lumalayo siya dun sa source. So kasi kapag halimbawa, ito yung source of signal mo, then na-reject mo yung signal. So once lumabas yung signal din sa source, then nag-propagate na siya, nag-travel na siya with a certain distance. So yung power level nun is lumiliit ng lumiliit habang lumalayo siya doon sa source natin. Okay? So kapag lumalaki yung distance from the source, so tumataas yung loss niya or mas lalo siyang nag-attenuate. Okay? So kaya kapag longer distances, mas malaki yung attenuation ng signal mo compared dun sa short distances. So that is the effect of the atmosphere of the Earth and the space mismo. Okay, so yung kasi yung niya, yung parang spreading. So sabi dito, this is due to the spherical spreading of the wave wherein the signal strength decreases while the distance from the source increases. So kaya din dito, din sa kanina, din sa power density, so kapag nag-i-increase tong distance natin from the source, so lumiliit yung power density. Humihina yung signal. Okay, so parang sa lang. For example, you have the router, yung Wi-Fi router mo. So, di ba, nag-ano yun ng signal. So, kapag mas malayo ka dun sa router ng Wi-Fi, so mas mahina na yung signal. Pero pag mas malapit ka dun sa router, which is the source of the signal, so mas malakas yung Wi-Fi connection. So, that is because of this relation, yung inverse square law. And of course, the attenuation. So, you can relate that doon. Kasi yun din naman yung principle behind, okay, dun sa ganong situation. Dun sa Wi-Fi router. So, parang siya yung source mo, then nag-emit yun or nag-radiate yun ng signal. Okay? So, we have also the absorption. So, the absorption is actually nangyayari lang yan sa atmosphere ng Earth. So, there is no absorption kapag yung signal mo is nasa outer space. So, may absorption kasi dito sa atmosphere ng Earth, so merong impurities yung air. Okay, so hindi kasi pure yung air, so may mga impurities. So some of the atoms or molecules nung atmosphere, so nag-absorb yun ng parts ng radio wave. Okay, so ang sabi dito, So the energy from the electromagnetic waves is transferred from, or it's transferred to the atoms and molecules of the atmosphere, causing some radio waves to be absorbed. So this is only possible sa atmosphere ng Earth. So there is no absorption sa outer space. So nabanggit ko nung unang lecture, magkaiba yung outer space at saka yung atmosphere ng Earth. So sa outer space, walang air circulation, so walang wind circulation, so walang absorption. Okay? Pero merong attenuation. So both yung outer space and yung atmosphere ng Earth, so parehas na may attenuation. So kahit saang medium, meron kang attenuation. So this is always present. So property kasi yun ng signal na mag-attenuate siya whenever na lumalayo siya dun sa source of the signal. But yung absorption, this is actually due to the impurities of the atmosphere. Okay? So again, walang absorption sa atmosphere ng Earth. Okay? Next. Since nabanggit natin kanina na yung electromagnetic wave natin, so para lang din siyang heat energy, para lang din siyang light energy, so meaning meron din siyang tinatawag na optical properties. So it actually has the same property with regards to dun sa mga dun sa mga physics properties like yung refraction, reflection. Okay, if you're familiar with the optical properties, so meron din ganun yung electromagnetic waves or the radio waves. Okay, so the first one is so this is the first optical property na meron yung electromagnetic wave. Same with light. So para lang din siyang light signal. Okay, so the refraction. Apat yun eh. So the refraction, the reflection, the diffraction, and the interference. Okay? So, ano yung mga terms na pwede nating i-relate dito? Like, simpler terms na pwede nating i-relate dun sa apat. For example, refraction. Ano ba yung meron sa refraction? It is the bending of the wave. Di ba? Reflection is the bouncing. Diffraction is the scattering. And interference is the colliding. So, those are the optical properties na meron din ang mga radio waves. Okay? So, the first one is the refraction. So, again, refraction. So, ito yung pag-bend ng wave. So, because of the changing density of the medium. Okay? So, kapag nag-travel yung wave from one medium to another medium, then magkaiba ng density yung medium, so, ang tendency ng wave mo is magbe-bend siya. So, that is known as the refraction. Okay? So, may kinocompute dito yung sa refraction. So, using this Snell's law. So, remember the Snell's law sa optics. So, ito yun. Parang ratio and proportion lang din. So, index of refraction nung una, tapos yung sign nung angle of incidence is equal to the index of refraction nung second medium times yung sign nung angle of refraction. Yung index of refraction, you can compute that if you have the speed of light and the velocity of propagation, o kaya yung velocity factor, or yung dielectric relativity. Okay? Relative permittivity. So, yung ER. So, meron din akong isang equation dito na nakita sa Tomasi. So, yung libro na Tomasi. So, meron siyang ganito. So, the frequency. So, kapag given yung frequency at saka yung electron density. So, meron siyang ganito. Ang unit niyan is electrons per cubic centimeter. So, based din sa nakita ko. So, ganyan siya. Okay? So, if may ma-encounter kayong ganong problem, then you can use this formula in solving for the relative permittivity. And then, pwede mo makompute doon yung index of refraction. Okay? So, yung refraction ng wave is actually depende dun sa ano. So, ganito siya. Let's say, for example, zoom natin ng konti. Yan. Let's say for example, yung nasa baba, yung medium 1. Yung nasa taas, yung medium 2. Okay? For example, this is your incident wave. So this is called the normal line. The normal line is the line perpendicular dun sa dalawang surface. So kung ano ito yung surface mo, so ito yung parang boundary nila. So medium 1, medium 2. So this will be the normal line. So dyan mini-measure yung angle of incidence at saka yung refraction angle or angle of refraction. So with respect palagi doon sa tinatawag nilang normal line. Okay? So if nandito yung incident ray, so pumasok siya dyan sa medium 2. So kapag galing siya sa less dense, papunta siya sa more dense, so ang mangyayari, ganito. Okay? Ayan. So mas maliit yung ano niya or mas malapit siya dun sa normal line. Okay? So, pero kapag halimbawa, yung signal mo or yung wave mo is galing siya sa more dense, papunta siya sa less dense, so ang angle of refraction mo is lalayo siya dun sa normal line. So, lalayo. It moves away. Okay? So, that is the property of the waves. So, pag sinabi mo kasing density, so parang thickness ng medium. So, kapag sinabi mong less dense to more dense, so pupunta siya sa mas thick na, sa thicker medium, so sa mas masikip na medium. So, kaya ang tendency, parang babagal yung wave. So, kaya mas malapit siya dun sa normal line. With respect dun sa normal line, no? Then, kapag kagaling siya sa more dense, then pupunta siya sa mas maluwag na medium, so less dense. So, mas bibilis yung wave. So, kaya lalayo yung angle niya dun sa, with respect sa normal line. Okay? So, tandaan nyo yun, no? So, kapag ka less dense to more dense, it moves towards the normal line. However, kapag ka more dense to less dense, it moves away the normal line. So, baliktad lang. So, you can compute the angle if given yung dalawang index of refraction ng medium and kung dapat at least merong isa dito given. So, usually, yung incidence angle yung given dyan. You can compute for the angle of refraction using this Snell's law equation. Okay? Next, the second property is known as the reflection. Okay, reflection is simply the bouncing. Kapag nag-bounce yung yung signal mo sa isang surface, so magre-reflect siya. So property 'yon ng wave natin. Okay? So this is different from refraction. Yung refraction kasi natin, nagta-travel siya from one medium to another with different density. So ito, hindi siya nagbabago ng medium. So nag-ano lang siya. Nag-bounce lang siya dun sa surface. So this is bouncing. Okay? So ang dito, so may two types tayo dito ng reflection. We have the what you call the specular and the diffuse. The specular is the reflection sa smooth surface. So pag specular, parang ganun lang. Okay, so smooth surface. Diffuse is yung kapag kakalat yung signal mo. Okay, so kapag rough yung surface. So pag smooth yung surface, specular yung reflection. Pag rough yung surface, it's called diffuse reflection. Okay, so kapag rough, kapag irregular yung surface. So, anong dapat tandaan dito sa reflection? Kung sa refraction, nagbabago yung angle of incidence at saka itong angle of refraction. For reflection, so this is actually called the law of reflection. So kung ano yung angle of incidence with respect sa normal line, yun din dapat yung angle of reflection with respect sa normal line. So walang change dun sa angle of reflection and angle of incidence. So meaning they are equal. So wala kang isosolve dito na kagaya nung sa refraction. Okay? Kasi reflection lang naman yung nangyari dun sa signal mo. Okay? So the third property or the third optical property is known as the diffraction. So the diffraction is the scattering or the redistribution of energy within a wavefront when it passes near the edge of an object. So parang lang to, yung kapag nag-scatter, kumalat yung signal mo, pag tumama siya sa isang obstacle. For example, this is your transmitter, then nag-propagate yung wave, tumama siya sa isang building, so yung edge ng building So, dun tumama, so kakalat dun yung signal mo. Okay? So, ang mangyayari nun, kapag tumatama yung main signal, so this is your main signal or the main wave, the primary wave, pag tumama siya sa isang obstacle, so yung mga edge ng mga obstacle mo, so nagiging parang secondary source sila, tapos nabubuo yung mas maliit na wave. So, ang tawag dun sa mas maliit na wave, which are the secondary wave, so yun yung mga wavelets. Okay? So, ganun yung property ng signal pagka tumama siya sa isang obstruction. Okay? So, nagkakaroon siya ng redistribution or the scattering yung tawag. So, nagkakaroon ka ng secondary waves na mas maliit kumpara dun sa primary wave. So, those waves are called wavelets. So, parang nagiging secondary source yung kung saan tumama yung primary wave natin. Okay? So, kumakalat yung signal. So, that's actually based on Huygens principle, yung binanggit ko. Okay? Huygens principle states that every point on a given spherical wavefront may be considered as a secondary point source of electromagnetic waves from which other secondary waves or the wavelets are radiated outward. So yung kagaya nga nung kanina, so you can actually consider this point and this point as secondary source of wave. Okay? Kasi dyan tumama yung primary wave natin. And yung tawag natin dun sa mga secondary waves is mga wavelets. Okay? Next, the last optical property na meron din yung mga radio waves natin is yung interference. So this is the colliding of the waves. It occurs when two waves that left one source travel different paths and arrive at one point. So there are two types of interference. So we have the constructive and the destructive. So obviously, magkakaroon ng constructive interference kung yung dalawang signal mo ay parehas yung phase. They are in phase. So pero kapag out of phase, so there will be a destructive interference. So makikita mo yan dito. So kapag in phase, parehas yung nila, yung phase angle and direction. So kapag nag-collide yung dalawang wave, so they will form a larger wave. So that's called the constructive interference. However, kapag opposite sila, no, magkaiba ng phase angle, so they are out of phase, and then nag-collide, so ang mangyayari doon, cancellation. So that is known as the destructive interference. Okay? So, those are the properties of the radio wave. So, similar yung properties niya dun sa properties ng light. So, ang tawag kasi dyan sa apat na yan is optical properties. Okay? Yung, eto. You can remember yung apat na optical property. So, by these terms, the bending, refraction, the bouncing, reflection, scattering, diffraction, colliding, interference. Okay? So, hanggang dito muna yung discussion ko for this day.